Please join me in welcoming to the Distinctive Voices podium Dr. Amy Hurst.
All right, thank you for that wonderful introduction. I believe this mic is on. Can the back hear me? Okay, great. Excellent. Just going to move that. All right, well, good evening. I'm going to start this talk with two case studies of existing do-it-yourself projects that we, myself and my students, have investigated. And these case studies will help motivate some of the possibilities of do-it-yourself assistive technology that I'm going to talk about this evening. In this first case study, I would like to introduce you all to Tom Jerry. He's a retired finance professional with an engineering degree who one of my students interviewed last year. Now, almost 40 years ago, as a volunteer, Tom walked into a children's hospital that was full of a room of paraplegic children who were either sitting on the floor on mats or they were using these ill-fitted adult-sized wheelchairs. So seeing this situation inspired Tom to create his first do-it-yourself assistive technology. These were homemade miniature wheelchairs. They were pretty simple. They were made out of half-inch plywood. They had upholstered seats and back cushions, a swinging utility tray that could help the kids get in and out very easily. Eventually, he also equipped them with lightweight sticks so that the children could push elevator door buttons. But the best feature about these chairs was that the kids absolutely loved them. And once he brought them, the children were instantly mobile and no longer confined to just sitting on the floor. And they used these chairs for years.
Is there a wheel in the back of the chair? Oh, what holds it?
Yes, so it's just two wheels, and then there's a rubber piece in the back, so the kids balance on it. All right. So since then, Tom has continued to build hundreds of assistive technologies out of his home workshop as a hobby. Now, all of these designs are actually freely available on his online community, workshopsolutions.com, where others can freely contribute their own designs. Now, I see this site as a wonderful collection of how easy it can be to solve unique accessibility problems with homemade solutions. Now, Tom's work and the work of the contributors who post onto his website illustrate that there are people already making and sharing their own assistive technologies. And in fact, Tom has received inquiries from people looking for solutions online, trying to pay for custom creations, and asking for more detailed instructions. And all of this implies that there's consumer demand for homemade assistive technology, and that people are already building things from the ideas that are shared on his site. Now, not only are Tom's designs both unique and practical, but they're also extremely affordable. His designs usually are built at a fraction of the cost of what it would be to buy a similar product. So for example, Tom's homemade wheelchair cup holder can be made with less than $2 of materials, while a commercial version will retail for about $110. Now, switching gears a little bit to the second case study, where we interviewed an art instructor who was working at a day center for individuals with motor impairments. And this instructor designed a head pointer that would enable people to paint without the use of their hands. So at this time of this project, there were several existing off-the-shelf solutions, and he bought a few of them, but found that they were really expensive, first of all, costing between $100 to $300, but also they were really difficult for the artist to use because as they would try and paint, these devices would slip around on their head and they didn't have very accurate control. So the instructor decided to create something better. And after a year of deployment and spending about $600 on supplies, he eventually designed a head pointer that was significantly less expensive, and the DIY solution was preferred over the artist's than the off-the-shelf solution. Now, while I view both of these case studies as success stories, and I believe that they demonstrate that it is possible to build assistive technologies instead of buying them, I see both case studies as having two pretty serious problems. Number one, the designs weren't made or designed by the end users. Instead, they were designed by the people with the tools. In these cases, one person was Tom, and then the other person was the instructor. Also, these designs aren't really that easy for other people to replicate. Many of Tom's designs require access to a well-stocked tool shop, and the designs that he posts online can be pretty difficult for novices to follow. And unfortunately, the head pointer design is just not online. So I am interested in further exploring how it is possible to empower individuals to do it yourself and make and design their own assistive technologies. So in the rest of this talk, I'm going to share my vision for how end users can build their own assistive technologies and how this can ultimately lead to an increase in assistive tech adoption rates. So I'm first going to talk about the recent do-it-yourself movement and two tools that I see being critical to this change. Number one, computer-controlled rapid prototyping tools that can make making accessible. And number two, online communities where users can share designs, experience, and knowledge. Then I'm going to talk about how do-it-yourself can increase assistive tech adoption rates and actually reduce adoption time by going through Rogers' 5 stages of technical adoption, which was first presented in the 1962 book, Diffusions of Innovations. As I do this, I will describe the role that rapid prototyping and online communities can play at each stage. Next, I'll summarize some of the recent high-tech and low-tech DIY AT projects that you may have seen in some of the recent news. And then finally, I'm going to discuss my own research projects in understanding and supporting do-it-yourself assistive technology activities. Okay, so here we go. So over the past few years, there's been an explosion and an interest in making objects instead of buying them. There's been a dramatic change also in valuing small-scale production over mass-produced items, and also on fixing things instead of just buying new replacements. And a lot of the motivation by this movement has really been pioneered by Make. And Make puts out quarterly issues of Make magazine, has a very active blog that features do-it-yourselfers, and then also organizes maker fairs where large groups, even 20,000 people, will come and see different kinds of things they have made. By the way, if no one's ever been to one of these events, one of these maker fairs, there's actually a mini maker fair that's happening in Providence, Rhode Island this weekend. That'll be very fun. I'll be there too. Okay. So this making trend can also be seen in the success of Etsy, which is an online marketplace where people sell handmade goods. And then also, if you're not familiar with any of those examples, perhaps you've heard of Martha Stewart, and you're familiar with her empire that promotes do-it-yourself through TV shows, magazines, and blogs. Okay, so making, it's pretty big right now. A lot of people are doing it. But are any of these tools accessible to people with motor impairments, sensory impairments, cognitive impairments? Well, traditional manufacturing machines such as bandsaws, lathes, and drill presses are, common making tools. However, these require many physical requirements of the users. These include the ability to stand, precise manual dexterity, and accurate vision, all of which limit whom can operate these machines. Furthermore, operating these machines requires special training and knowledge and can be extremely dangerous when misused. So I believe that personal scale manufacturing tools may be the solution to making making accessible. So I really like this quote from Hod Lipson saying that personal scale manufacturing tools enable people that have no special training in woodworking, metal smithing, or embroidery to manufacture their own complex, one-of-a-kind, artisan-style objects. So a new generation of affordable rapid prototyping or personal scale manufacturing tools really make it possible for individuals to build and customize physical devices, such as wheelchair accessories, prosthetics, tools to support activities such as eating, dressing, art, and learning. Now this new generation of tools remove a lot of the barriers that we see with traditional manufacturing tools because they're computer controlled. And to create something for one of these machines, a user only needs to be able to access a computer and then create or even download a file in the correct format. And I think that this really creates an exciting opportunity for individuals without mechanical engineering or manufacturing backgrounds to build things. So for those who aren't familiar with these tools, I'm going to go over them very quickly in the next few slides. And I'm going to highlight some of these tools that are do-it-yourself, where you can actually make your own machine that can make things, hobbyist versions of these machines, or professional versions of these machines. So the first category of tools I want to talk about are additive 3D printers. So these can build 3D objects out of plastic, ceramic, or metal. And in the past few years, there's been an influx of both DIY and hobbyist printers that can print objects for plastic for under $2,000. Now, professional 3D printers start around $10,000 and can create objects out of more alternative materials. Okay. So laser cutters are able to cut and etch a variety of objects, such as wood, fabric, paper, and plastic, using the light from a laser. Now, DIY and hobbyist laser cutters cost around $5,000, and then professional ones start at $15,000. And then finally are subtractive CNC routers and mills. And these tools start with a large piece of material and then remove pieces to get the final object. And it can generate objects in either 2D or 3D. And can create using a range of materials such as metal, wood, or plastic. And the DIY and hobbyist kits are usually priced around $1,000, while professional ones are more in the $8 to $10 and up range. And then the professional routers are able to cut much larger materials than the DIY or hobbyist, and also are more precise. Okay. So all of these tools can vary dramatically in price. And as I mentioned, there's a large open source hardware community around making these tools affordable and also making them more widely available. However, if one doesn't have access to one of these tools, there are many services, such as Shapeways, where one can actually upload a digital file to a website and then receive the manufactured object in the mail. Also, local workshops are popping up all over the country in the form of hacker spaces, fabrication labs or fab labs, and tech shops where anyone can actually buy time on these machines, or maybe a group of people would go in and buy a machine and then share it. So in addition to new manufacturing tools, there are also a lot of new online communities that enable users to share their designs, modifications, experiences, knowledge, and inspiration. And two of the examples that I find particularly interesting are Instructables and Thingiverse. And I'm going to quickly go over those two websites in the next few slides. Now, both of these websites employ different kinds of social media feeds, such as RSS feeds, Twitter, Facebook, email, all of these different kinds of ways to reach people that can encourage participation and keep people up to date on the latest projects and developments. So, as promised, Instructables is a website where users can upload photos and text instructions to build almost anything. So here's an example. One of my favorite things on Instructables is a Dachshund wheelchair for a dog. So this site is really very active, and it hosts a wide diversity of projects. However, there are no rules for authors about how they're going to describe the designs, the parts they're going to use to build anything. And there's also not a lot of structure to find out if others have followed your instructions and actually recreated any of your designs. And in many ways, I see Instructables as very similar to Tom Jerry's website, Workshop Solutions. Okay. And then the other website is Thingiverse. So Thingiverse is an online community that's geared towards making and requires its users to share files to build their designs. So unlike Instructables, on Thingiverse, uploading a photo of whatever it is you're going to make is not enough. You have to include all the files that you need to actually make it using one of these machines. Now, the most common files on Thingiverse are files to be 3D printed or laser cut. And I see that this website is really helping lead the way in the open source hardware movement. and they encourage users to modify designs and then repost changes, much like a software repository where you see the evolution of the design over time. Now, like Instructables, Thingiverse encourages users to share images and experiences about making the designs hosted on this website. However, it includes the infrastructure to fully support this activity. So in this example here of a pillbox that fits inside one of those Altoids mint tins, we can see both the 3D rendering of that model, and then we can also see the versions of it that users have printed. Okay, so that was a whirlwind tour of some of the relevant rapid prototyping and online community tools that I think can be useful for do-it-yourself assistive technologies. If you're interested in learning more about this area, I would encourage you to look at some of the more recent versions of Make Magazine or even looking at the Make-Zine blog. So in the next section, I'm going to investigate the role that do-it-yourself can play in the adoption of assistive technologies. So despite the tremendous potential of assistive technologies, a surprisingly large amount of it goes unused. So Phillips and Zhao have reported an overall 29.3% assistive technology abandonment rate. And I believe that by empowering individuals with the means and knowledge to create their own assistive technologies and then iterate on these designs as their needs change, they will have full control over most of the factors that are problematic in adoption, such as user opinion, speed of delivery, performance, and also understanding user needs. So in the next few slides, I'm going to introduce you to Roger's 5 stages of technology adoption and discuss how rapid prototyping and these online communities can help increase the likelihood of adoption. So Rogers has developed these 5 stages. And the first 3 stages are really the build-up to the individual deciding whether or not they're going to try or choose that piece of technology. These include knowledge or awareness of the technology, persuasion to adopt the technology, and then that decision to adopt or maybe not adopt it based on the information from the previous 2 stages. Now, the last 2 stages focus on what happens after it's been adopted. So those include the implementation stage, where someone will actually test this technology in everyday life, and then finally a confirmation stage, where they will figure out, was a good decision made, am I going to continue this, is this going to be part of my, going to be long-term adopted. So the first stage in adoption is knowledge about the technology. And I see that online communities and services can play a large role here to help individuals find out about new technologies or solutions. They can browse catalogs on online stores. And also we're seeing that professional and personal news feeds, articles, blogs, Facebook accounts, and Twitter forums are really providing, serving this role here, helping people find out about the technology initially by kind of hearing buzz about it. Now, access to online communities with information about how others have used, modified, or designed their own technology can also help persuade. So I really like this quote from Rogers, who said, "When someone who is like us tells us of their positive evaluation of a new idea, we are often motivated to accept it." Now, this kind of persuasive design is built into many online sites, especially those with active user reviews. Here I've included an example from Amazon, where you might look at a given product and then see how many other people have used it and what ratings they've given for it. Or we also see this in the way that Thingiverse will make the number of people who've built an object visible. So you'll see an object and say, that looks interesting. Look, 20 different people have printed it. I'm going to do it too. Or they also encourage users to post their successes. Look, I printed that pillbox, and that piece fit perfectly in the Altoids tin. Or, oh, maybe it didn't. I printed it a little bit too small. So sharing both success and failures to help with the persuasion. So in the third stage, the user makes the actual decision to adopt. And then they need to test that technology before really making that decision. So when we were doing the work where we were interviewing the instructor who designed the head pointer on a paintbrush, He said that it was really difficult to make decisions about the off-the-shelf solutions just from the descriptions in the catalogs, and really didn't want to waste money on things that didn't work. So I believe that rapid prototyping can help a user test their design or someone else's design very quickly. So here we have an image of the progression of a prototype that was used during different manufacturing methods that have different costs. So on the left, we have a 1-cent plastic prototype, and then we see this get to a more expensive metal cast. So this provides someone to test it before they actually make the decision. So if it's not possible for someone to prototype or test this technology, trial by a peer can also serve this purpose. So online communities can come into play here, where we can watch a video of someone else opening up the product or interacting with it, and we can then learn from that if we're going to make the decision to adopt or not. So once the decision has been made, it's time to implement or actually do some real-world testing of the technology by incorporating it into your life and then using it. So during this stage, problems may come up, the technology may not be quite what you want, and then the user may choose to reinvent or actually modify the technology if there are places where it's not quite right. So when developing the head pointer paintbrush, the instructors first bought the off-the-shelf solution and then started reinventing it as they explored different design improvements before they came to their final design. So here we have an example on the far left of the expensive off-the-shelf solution, and then they tried modifying it with just a helmet that had a paintbrush on it. And then someone had the idea, well, you know, maybe we need one of those paint masks where you can kind of screw it into place and it holds very firmly. And then they did that and took the shield off and attached the paintbrush there. So we see the different stages there in reinventing. So at this point, I want to take a brief moment and talk about the duration of this process. So currently, the greatest slowdown in the AT adoption process is between the decision and the implementation stage, when the user is usually waiting for the insurance company to approve that technology. However, do-it-yourself assistive technology can help users avoid this delay or other potential holdups because they are in control. They're not dependent on a third party, and they have access to all of the information they need in that given stage. So the duration of an adoption process is extremely important as user needs change. And as user needs change, they may not even need the device by the time it came if they went through traditional methods. So the final stage is confirmation of the user's choice. Here the user decides if the technology is actually appropriate or not after they've used it for a while. Now, online communities here can play a role by helping, by providing information about how others have used the technology, or by sharing experiences about modifying the technology, sharing everything that happened in stage 4 here. Now, this information can also become useful for those who are just starting the adoption process and are looking for technology. So in other words, all the things that happen in stage 5 can be useful for people in stage 1. Okay, so by developing or identify technologies to help in these 5 stages of adoption, I believe that it'll be possible to improve the adoption rates of assistive technology. Now, before I discuss my own research, I want to briefly introduce relevant do-it-yourself projects that help further illustrate the potential of do-it-yourself assistive technology, and have also motivated some of my own research. Now, along with the success of the do-it-yourself movement, we're starting to see more and more assistive technology projects in the DIY space that are being discussed online, again, feeding into that first stage of adoption. Some of these examples that I particularly like include the iWriter, which is on the top left, which is a system that was created to help a paraplegic graffiti artist continue to create art by just controlling his eye, by moving his eyes. Next, on the top right, is the Open Prosthetics Project, which is working to open source or make freely available different kinds of designs for prosthetic devices. And I think one of the things that's really interesting about this project is they have made many different designs that are no longer commercially available online and for people so that people can make it, but they can't actually buy it anywhere. And then finally, the Magic Arms project that was just in the news within this last week is about 3D printed arms, kind of an exoskeleton that goes around the arms to help this little girl be able to easily move her arms. And the thing that's unique about this project is the exoskeleton is made out of 3D printed parts, so they can just reprint any part as she grows and then outgrows that. Now, while these projects are really exciting and I think they make a tremendous impact, all of them still fall into that same problem with Jerry's work and the head pointer, that they were technology that was made for someone else and not an individual making it for their own use. So using rapid prototyping tools for assistive technology is also starting to appear on websites such as Thingiverse, including this right angle spoon and this foil top opener. Now I'm really excited actually about this foil top opener because it was one of the first examples that I saw of do-it-yourself assistive technology in the wild. So in the posting, going along with the file to print your own foil top opener, the designer explained that they designed this tool to help them open applesauce containers, which is something that they have to do daily to take their medication because it's very difficult for them to open these due to a motor impairment. Now, while most of these high-tech projects are still being done by experts and not end users, there are many low-tech projects that are simple enough that the end user could actually make the device for themselves. For example, I like looking at Therese Wilcomb's work. She's known as the MacGyver of occupational therapists, and she uses tapes, adhesives, and fasteners to mount and modify switches, fasteners, and padding. In her book, Assistive Technology in Minutes, she demonstrates a wide range of adaptations that can be made with a single material. So for an example, here's a page in her book that demonstrates how clay can be used to adapt pens or mice for people with dexterity limitations. The book Disabled Village Children by David Werner offers easy-to-follow examples for how to build splints and braces for third world village children out of materials such as sticks, branches, or cups. So the image on the right demonstrates how crutches could be built out of just branches and some fabric. Okay, so in this final section, I'm going to discuss some of my research to understand and support do-it-yourself assistive technologies. And I'm going to talk about 3 projects. One is understanding interest in DIY AT, another one on effortless 3D modeling, and then finally accessible fashion. So my students and I have been conducting interviews to gauge desires and interests of non-engineers, people for whom traditional making is not accessible. And we've been talking to them about building or modifying their own assistive technologies. So in order to gauge interest in DIY IT, we conducted these interviews with power wheelchair users about what modifications they would want to make to their assistive technologies. And they all had lots of ideas about modifications to their wheelchair that they thought would make it more fun, useful, or comfortable. And we were surprised that almost all of these were relatively simple and very doable. These include things like making the chair more car-like, store a phone securely on an acrylic tray, having a seat warmer and a massager embedded in your chair. Lots of really great ideas. Now, while most of people had ideas like this, there was one participant who was interested in much simpler functionality, such as all he wanted to be able to do was drink from his cup of water through his straw and have access to the time. And he was actually impressed and honestly a little jealous that one of the participants in these interviews had a clock that was mounted to her AAC device. He had never thought of that before, and by taking just one look at that, he had an idea for exactly where it should be mounted on his wheelchair and how. So overall, our participants had a really strong interest in do it yourself. And they saw this as a good way to get the things that they needed. And these participants were also interested in learning new skills, including starting to look at 3D modeling and design, so then they could actually have control over these modifications. Additionally, one of our female participants was very interested in customizing the color of her assistive technology. She was very sad that her communication device was pink and her wheelchair was purple, and she really wished they were the same color. So overall, we saw a trend that participants were willing to make modifications so long as it didn't void any warranty. They were even willing to let someone else modify their wheelchair and then break their warranty if they were still involved. However, not all participants were concerned about warranties or even being involved. One participant simply said, "When it breaks, I stay in bed." And this referred to a 2-month period where his wheelchair was broken and he was not able to go out and do the things he wanted to do and just had to stay in bed. And this quote really hit home for me that DIY provides a unique opportunity for empowerment. So in my lab, my students and I are working to create tools and frameworks that empower people to solve their own accessibility needs. So tonight I'm going to talk about 2 projects that we're working on. The first project is focused on developing tools that empower novices, people without any programming or engineering background, to easily create objects on 3D printers. And then the second project focuses on making fashion accessible to people with vision impairments and explores how we can leverage crowdsourcing to answer subjective questions, and then also how we can embed information into our clothing. So many of the tools for 3D modeling are complicated, and they assume programming or mechanical engineering training. Now, while there's a new generation of tools such as Google SketchUp or Tinkercad, these represent a trend towards supporting novices in 3D modeling. They can still be difficult for individuals with vision or motor impairments to use because they require precise manual refinement of these 3D objects. So what we're doing is we're working to develop accessible tools that enable these groups to effortlessly create 3D models. So in this section, I'm going to discuss our project creating software to generate 3D printed tactile graphics for math and also Braille labels. So most students prefer to learn mathematical concepts such as functions, graphs, and plots visually. However, individuals with vision impairments tend to learn this information tactily. To better understand how this is done, we interviewed individuals with vision impairments who either use high-level math in their jobs or took these kinds of classes in college. Now, unfortunately, many of these current solutions are less than ideal. Many of these visualizations are handmade, such as this one, using glue, glitter, string, or other kinds of materials. Or maybe you're a little bit fancier and you have a handheld embosser where you can actually draw these tactile visualizations. Now, while these handmade solutions are very affordable, they are pretty time-consuming, and also they're not made by the end user. They require someone else to make it for you. Now, currently, the best alternative to handmade graphics are to create them on Braille embossers. Unfortunately, these machines are very expensive and not often available to students. Now, to help students have access to accurate, customizable, and affordable tactile graphics, we've developed software that makes it easy to automatically create tactile visualizations of math on a 3D printer. So we've developed software that's called VizTouch, and this enables a user to easily create a tactile graphic by simply uploading an Excel spreadsheet or typing in an equation. So the above image demonstrates the VizTouch user interface, and as you can see, it's designed for novices to 3D modeling. So the user will upload their file, type in the equation they want, give it a title, and then press the OK button. And then their model will be automatically generated. So here's an example of the output from VizTouch. So on the left, this is the 3D model that was automatically generated as the result of interacting with that interface. And the image on the right shows the corresponding output from the 3D printer. So in our current prototype, it takes about a minute to generate that 3D model, and then about an hour to print out that graphic on our 3D printer. So we have evaluated the output from VizTouch with many individuals with vision impairments, and they're pretty excited about having this as an alternative to the current solutions. In our interviews, we actually learned that the handmade solutions are very laborious and can take several hours to create a single graph. Now, while embossers are faster than making graphics by hand, they're also limited in that they don't have the resolution. So this can be a real problem in the current solution because students learning math just don't have access to the same number of examples that sighted children do. So going back to our prototype, this slide illustrates output from VizTouch from an Excel file. So on the left, we printed this graphic using only one color of plastic. And we showed this to participants who were both blind and low vision. And the low vision participants actually wanted to have high color contrast. So we've also made an adaptation so now we can print it with two colors of plastic. So you can have both visual feedback and tactile feedback on these. Now the current output from VizTouch makes these little plastic cards. They're roughly 3 by 5 inches. Now, since this may not always be large enough to convey a full graph, we've also successfully built and tested prototypes that can combine several of these cards to create a much larger one. Now, you may have noticed that these prototypes use Braille for some of the titles and the access labels. So one of my students has created a system that's going to be incorporated into VizTouch that can allow alphanumeric characters to appear under the Braille. This way it can be accessible, again, both to people who are blind or low vision. But the alphanumeric characters are flat, so they don't actually interfere with the Braille. So our work on VizTouch has been focused on creating new 3D models. But what happens if you want to edit something that someone else has designed? So as I mentioned, Thingiverse is the website where people can upload designs that they've made. And this website is full of all kinds of useful models that already exist. But what happens if you find one that's not quite right for you? So let's revisit the example of the right-angle spoon or the foil top that I previously mentioned. Maybe they're just a little bit too small for your hands, or maybe they're not quite right for the food that you're trying to eat. Well, what we're doing is we're working to explore what kinds of tools we can develop that can make it very easy for novices to customize these designs that someone else has created. So basically, can someone do the very hard work, and then we can do software that can make these small customizations. So in this project, we're focusing on accessible solutions that enable end users to take accurate measurements. Ideally, we want people to be able to take measurements at home and not have to go to a clinic, a hardware store, a doctor, wherever. So we've been thinking about the following questions in evaluating measurement tools. What's available? Some of you may be familiar with recent advancements in 3D scanners. And 3D scanners are great, but they're very expensive. And also, the output on them often requires a little bit of cleanup, and that might not be accessible to our target population. Also, we're thinking a lot about what is easy to operate. And in this, we're considering vision, sensory, and also cognitive impairments. And finally, accuracy is a big challenge. Thinking about how precise do any of these measurements need to be, and how do you communicate exactly what measurements are needed, again, in an accessible way. And then, what happens if you take a measurement and it's incorrect? How much of a burden is it going to be for someone else to retake that measurement? So as a first step towards answering these questions, we've created Nickel for Scale. And in this project, we've built a system where you can take measurements from images of an object using a reference object. So in the example here, we're measuring my hand, and the reference object is a nickel. So everyone has nickels lying around. You can just take a nickel, put it on your hand, and then put your hand on the camera, And that's all you need in order to take a measurement. And then from this, we're able to build 3D models that are parameterizable, which basically means it can take in any value. So it could then make an object that's 2 inches, or easily scale it up to 5, or 2.2 inches, or whatever your measurement is. Currently, this implementation works best on hands, and we've used it a lot to size rings and finger holes and different kinds of handles. But we're looking to expand this on what we can do with this kind of model. OK, so the final project I want to talk about is focused on making fashion accessible. So fashion is a language. How we dress signals to others who we are and how we want to be perceived. However, this language is primarily visual, making it inaccessible to people with vision impairments. As a result, individuals with vision impairments have a lot of questions about their fashion choices and the choices of others. So in this project, we're exploring potential solutions that can help answer these questions. So as a general trend, when it's not possible to get questions on your own, individuals will turn to someone else. And right now, many people are turning online for help. Again, a trend we saw going through the second stage of adoption. So we're collaborating with researchers from the University of Rochester who have developed a VizWiz. And this is a system where a user can submit a question. They can take a picture of anything with their phone, record an audio question of that, and then get an answer for that question all over the world. So you could literally take a picture of Joanne's shirt, ask what color it is. Someone in India may tell you it was a white shirt. You can get your answer that way. So we've been exploring how individuals with vision impairments would use VizWiz service to get answers to questions about clothing and their fashion choices. And we've seen that these questions that people ask go beyond the simple, what color is this? Something that could be very easily answered by some of these color identifier apps that you can get on your cell phone. And instead, people are asking much more complex, subjective questions, such as, does this polo shirt go with these trousers? And what other things in my closet does it match? Or my personal favorite is on the far end, which was a grandfather asking, what is the color of my grandson's shirt? He's turning 10 today, and I want to make sure I can take him out in public. Yeah, write an algorithm to answer that one. Now, while some of these questions may be best left to the crowd, ones that are dependent on current fashion trends, or if a specific garment is clean or wrinkled. Others may be a lot more simpler and static, could actually be embedded in clothing. So as an example here, while interviewing with individuals with vision impairments about how they organize items in their closet, some of them actually would tag clothes with safety pins or ribbons so they could keep track of lights versus darks or washing instructions. Now, while this is a pretty cool do-it-yourself hack, these systems can only provide so much information. And we're exploring potential solutions that could embed even more information so someone could easily ask questions as, what does this shirt say, without the help of anyone else. So we've built some high-tech prototypes of these systems that could embed really any amount of information in clothing. And we're exploring how these kinds of tagging systems could work. So we're looking at sewing in RFID tags, or even taking a picture of a QR code that maybe you iron into your shirt, or maybe you just take a picture of the shirt. And then you could index that information. So our goal with these prototypes is that the user could get any of this information easily through their phone or some other kind of reader without the assistance of anyone else. And in addition to exploring these high-tech solutions, we're also looking at some low-tech alternatives where the user would simply say or maybe even type in a number or a shape to identify a garment. So for example, we're looking at creating fabric tags that have Braille characters on them that could uniquely identify anything in their closet. Another alternative is to sew unique buttons into specific areas of clothing to help identify the clothing. So then the user could simply identify the shape and location, such as it's a star on the collar. And of course, for those who were paying attention before when I was talking a lot about 3D printing, I've spent a lot of time thinking about how can we make custom 3D printed buttons that are very unique and maybe also expressive or desirable to have on the clothing. Okay, so this summarizes my current research on new technologies that can support do-it-yourself assistive technology. So tonight, I have explained how it is possible to build assistive technology that is affordable, customizable, and useful. And I believe that applying these DIY tools and culture to accessibility problems, we can increase adoption rates and empower many individuals. So the work I have presented today represents the ideas and hard work of myself and many collaborators from the University of Maryland, Baltimore County, funding from the CRA Distributed Research Experience for Undergrads program, the University of Maryland College Park, the University of Rochester, and also MakerBot Industries. And as it happens, my collaborator, Robert McGuire, is in the audience today, and if you have the chance, you should wish him happy birthday. All right. Thank you so much. If you're interested in learning more, feel free to check out my website, send me an email, or read any of my papers on these projects. Thank you.